good afternoon friends. I welcome you all in this session. As you are aware, in previous session we were discussing about estimation and we have seen point estimation and interval estimation. It is always good to have interval estimation because it gives you range. So, there is a higher probability that your estimation would be within a given range. So, let us work out couple of examples related to estimation. So, let us take a sample of 11 circuits from large normal population and has a mean resistance of 2.2 ohms. So, mean is given. So, n is 11, right, and mean is 2.20, right. We know from the past testing that the population standard deviation. So, sigma is also given, right, is 0.3 and you have been given this is nothing but your population mean, right. Determine a 95% confidence interval for the true mean resistance of the population. So, we are looking for population mean, okay, and in fact this is your sample mean, right. This is not population mean, this is sample mean. We have to estimate population mean, right. So, this is how you should be proceeding. This x bar plus minus z alpha by 2, right. So, this is your distribution, right, and this is in fact this is 95%, right. So, this is 2.5%, right, and this is also 2.5%. So, look at the value of z from z table, and at 95%, as I said, it is 0.95 divided by 2, so 0.475. So, look at the z table where probability is 0.475 and you will find that it is at 1.96. Okay. So, 2.20 plus minus 0.20, right. So, this is your interval, right. Okay. So, what does it mean? So, we are 95% confident that the true mean resistance is between 1.99 ohms to 2.40 ohms. Again, the true population mean may not be in this range, but what we are saying is that 95% of the intervals formed in this manner will contain true mean. In this manner means let us take one more sample of sample size 11, right, calculate its mean and again come up with this confidence interval. So, when you frame these confidence intervals, so 95% of the intervals will have population mean. Let us look at one more question. So, Discount Sounds has 260 retail outlets throughout India. The firm is evaluating to open up a new outlet. So, based on the income of the people, the firm decided to go for a study. When the firm selected 36 households and it was found that the sample mean income was 31,100 rupees. The population mean is not believed to be rightly skewed. The population standard deviation is estimated to be 4,500. So, sample 36, population mean sample mean is 31,100 and standard deviation is 4,500, right. So, we have to find out confidence interval at 95% level. So, it is similar to what we have done in previous example. This is there. So, this x bar plus minus z alpha by 2 under root of sigma by n, right. So, this what is the value of, this is the z table value for 95% significance level, right. So, this is a margin of error and you have got mean. So, mean plus minus this, right. So, what was mean? if you look at previous slide, so mean is 31,100, right. So, 31,100 plus minus this, is not it. So, this is the interval estimate of income. So, we are saying that 95% confident, we are 95% confident that the interval contains the population mean, right, and it has got the same meaning. If we take, let us say, one more sample of sample size, let us say 36, we will calculate its mean, we will again find out intervals, and like that when we have let us say 100 intervals, then out of 100, 95% of the intervals will have population mean. Okay. So, we have seen we can have not only population mean, but population proportion, population variance as well, right. When we talk about population mean, we can have two situations, either standard deviation is known or a standard deviation is unknown. In real life, we generally, in fact, we really do not know standard deviation of the population. So, do you ever truly know standard deviation? No, because to find out standard deviation, you need to know mu, right, population mean. So, once population mean is known, there is no need of doing this exercise, is not it. Why are we doing this exercise? Because we want to know from sample mean, we want to know population mean, right. So, if there is a situation where this is known, then this would automatically be known, because standard deviation can be calculated with mu, right, and if mu is known, there is no need of doing this exercise, right. So, you really do not know standard deviation of the population. So, what to do in situation like this, when you do not know the population standard deviation? In situations like this, it is always good to use sample standard deviation, which is S, right. So, this introduces an extra uncertainty, because S is a variable from sample, and of course, it varies from sample to sample, and it is the standard deviation of sample, right. So, we will use a distribution called T distribution rather than Z distribution. Okay. So, let us look at a couple of assumptions for finding out confidence interval of, let us say, population mean when this is unknown, right. So, we will say that standard deviation is unknown, and but the population is normally distributed, this is our assumption, and even if the population is not normally distributed, then you need to take a large sample size. Okay. So, either you call it T distribution or students T distribution, is one and the same thing, right. So, confidence interval estimate is this, is x bar, this is the sample mean plus minus this is T alpha by 2 rather than Z alpha by 2, because we are using T distribution. So, this is the where T alpha by 2 is the critical value of T distribution with n minus 1 degrees of freedom, and an area of alpha by 2 in each tail, right. So, it is similar to what we have seen. So, this again alpha by 2 and this is alpha by 2, and this is 1 minus alpha, right, this area is 1 minus alpha. Okay. So, let us look at what is the meaning of degree of distribution, and before this, T distribution is nothing but a family of distributions, a family of curves, and the shape of each curve depends on the degree of freedom. So, the number of observations that are free to vary. So, what is degree of freedom? The number of observations that are free to vary after sample mean has been calculated. So, this degree of freedom n minus 1. So, whatever is your sample size, let us say if it is 10, then degree of freedom would be 19. and its meaning is that the variable which are free to choose. Let us take an example. So, let us say there are 3 numbers x1, x2, x3, and the mean of those 3 numbers is, let us say, 8. So, you have got x1, x2 and x3, right, and their mean is let us say x1 plus x2 plus x3 divided by 3 is equal to 8. So, this 8 is given, and for example, let us say x1 is 7 and x2 is 8. If you put x1 is equal to 7 here and x2 is equal to 8, then x3 has to be 9. X3 would be 9. You can't have any other value of x3. So, let us say if there are 3 variables, then you can freely choose values of x1 and x2, not of x3. Or in other words, if there are 3 variables, let us say x1, x2, x3. So, if x3 is chosen, x2 is chosen, then x1 is fixed. So, if there are 3 variables, you are having only 2 variables for which you can freely choose their values, right. So, that is the point written over here, number of observations that are free to vary after sample mean has been calculated, right. So, this is degree of freedom. So, n is equal to 3 means degree of freedom 2, right. If n is equal to 7, degree of freedom would be 6, right. So, 2 values can be any number, of course, but the third value is not free, because third value would be determined by these 2 values, is not it. So, this is degree of freedom. So, if you look at the difference between t and z test, then you will see that as we increase sample size, the t distribution becomes z distribution. So, let us look at these are different t distribution curves. So, if you look at this one, this curve, right. So, it has got degree of freedom 5, right. Let us call this A, right. This curve, this one, this curve, let us call this one as B, right. So, it has got degree of freedom 13. So, what is the difference between curve A and B? Curve A is flatter, right, it has got more dispersion, right, compared to curve B. And let us look at this, this is curve C with degree of freedom infinite. So, this at t is equal to infinity, sorry, at degree of freedom equal to infinity, t distribution becomes z distribution, right. So, t distributions are bell shaped and symmetric, but have fatter tails than normal curve. This is the difference between these two. This is one more example. So, you have got this curve with n is equal to 25 and this curve with n is equal to 10, right. So, the curve which has got higher value of n is more towards normal curve, right. So, this is comparison of 2 distribution and 2 t distribution and standard normal curve, and this one is normal curve, right. So, how to look at a value of t distribution in t table? So, let us say this value is your 1 minus alpha, this 90%. So, this value is 1 minus alpha, it means remaining 2 sides has to be alpha. So, we are equally dividing this area. So, this portion would be alpha by 2, this would be alpha by 2, right. So, let us look at one more example. Let us say this entire area is 1 minus alpha, let us say 1 minus alpha, then this becomes alpha, because this total is 1. So, 1 minus alpha plus alpha, this becomes 1, is not it? Let us say if this is, let us say 1 minus alpha is 95 for example, then this becomes 2.5 and this becomes 2.5, is not it? So, let us say degree of freedom is 24, it means n is equal to 25 at degree of freedom. So, the degree of freedom would be 24 and t value is, just look at in t table. So, this is t table at t is equal to 24, this is 1.71, 1.711 is t 0.05, right. So, this is t 0.05, right. Okay, let us look at this. In fact, you can have different ways of representing t tables in different books, right. So, this is one of the t tables, it is quite a standard table. So, if you look at this table, this area is alpha, right, this one, this is alpha and this remaining is 1 minus alpha. Okay. Now, let us see what is the value of t at degree of freedom equal to 24. Okay. So, what was the value of 1 minus alpha? Here it was 90%, right, is not it? So, this is 90%. So, we will go to this table once again. So, this is 90%, is not it? This is this is again 5% and this is again 5%, is not it? This is 90%, this area is 5%, this area is 5%. So, 5% means 0.05, is it? So, look at 0.05 in this table, which is here, this is 0.05 at degree of freedom equal to 24, right, this is somewhere here, right, is not it? This is 1 point, so this is the answer, 1.7109, which you can see here, 1.71. Okay. Let us look at one more table, because you need to understand how to find out t value in t table. So, let us say confidence level is 80. So, when I say confidence level is 80, it means this area is 10%, right, this area is 10% and this area is 10%, right. So, 10% means you just divide it by 100, right. So, 0.10. So, 0.10 is here in this table. Okay. Now, at degree of freedom is equal to 10. So, this becomes 1.3722, which is here, is not it? If I ask you to calculate, to find out t value at 10 degrees of freedom when confidence level is 0.90. So, what would you do? This is 0.90, right. So, this is 0.90, is not it? So, this side would be 0.05, because this is in other words 0.1 by 2 and this also 0.1 by 2, right. So, this 0.05. So, 0.05 is here, right, and 10 degrees of freedom, this is the value 1.8125, 1.812, is not it, and so on, right. So, this is how you should be looking at t table for solving a question. So, let us look at this example. A random sample of 25 has mean is equal to 50 and standard deviations, this sample standard deviation 8, form 95% confidence interval for population mean, right. So, we have to look at t value in t table at degree of freedom equal to 24 and this 0.95, right. So, this is 0.95, so this is 0.025, this 0.025, isn't it. So, look at the table, 0.025 is, this is the one, right, this column. Okay. So, 0.025 and at what degree of freedom? 24, right. So, 24 degrees of freedom is this is the, this 2.0639. So, sample mean is 50 plus minus t value s upon under root 10, right. This is sample standard deviation. So, the confidence interval is 46.69 to 53.30, right. So, what does it mean? It means that the 95% of the confidence intervals so framed would have population mean in this range. Okay. Let us look at this question. 7 homemakers were randomly sampled and it was determined that the distance they walk in their housework had an average of this much miles. So, sample size is 7, x bar is 39.2 miles per week and sample standard deviation, this keep in mind, this sample standard deviation is 3.2, S is this. Construct 95% confidence interval. So, how would you do it? 39.2 plus minus, we have seen the value of t in previous example. So, but it was at 24 degrees of freedom, here we will have to check it 6 degrees of freedom, isn't it. So, n is equal to 7, it means degree of freedom is equal to 6. So, this is 0.95, this is 0.025, right. So, look at table, we will go back to table. So, at 6 degrees of freedom 0.025, right. So, this is 0.025, 6 degrees of freedom is 2.44, right. So, 2.44 into S is 3.2 divided by sample size, right, under root of sample size. So, this is how you should be calculating this and the answer is this in this range. Okay. So, this is how you should be calculating confidence interval range when the population standard deviation is unknown. Let us look at one more example which is a simple one. A reporter from a student newspaper is writing an article on cost of off-campus housing. So, he selected 16 apartments. So, n is equal to 16, degree of freedom is equal to 15 and within half mile of the campus resulted in a sample mean, this is 650 and sample standard deviation is 55, right. So, how you should be solving it? 650 plus minus whatever is your t value into S is standard deviation is 55 divided by factorial n. What is n? N is 16, right. So, you have to just look at t value for, of course, confidence interval is there in next slide. So, at 95% confidence interval you have to find out t value. Okay. So, what is the answer? Of course, the answer is, of course, you can calculate answer and the answer would be, first of all look at t value, this is 2.131 at 15 degrees of freedom, okay. And then you can solve this question, right. 650 plus minus t value, sample standard deviation divided by under root of sample size. So, this is the range, right. 650 plus minus 29.30, which would be this, right. So, we are 95% confident that the mean rent per month for the population of efficiency apartment within half mile from the campus is this, right. You can work out this example. Of course, I will give you solution, but the question is like this. An insurance company has the business of objective of reducing the amount of time it takes to approve application for life insurance. So, this approval process has got several steps. It consists of underwriting, which includes a review of application, medical information about the client, right, a possible request for additional medical information and medical examination, and a policy compilation stage in which the policy pages are generated and sent for delivery, right. So, you have collected data by randomly selecting a sample of size 27 approved policies during period of 1 month. Now, you organize the data collected in the worksheet, and this table consists of this time estimates in days in, right. So, processing time was 73 for one application, for some other applicant it was 17 and so on, right. So, you have been given 27 samples, right. You are supposed to construct a 95% confidence interval estimate for the population mean processing time. So, this is a case of raw data, right. You have not been given mean, you have not been given standard deviation, isn't it. So, first of all, what you should do, calculate mean and standard deviation and then put those values in the formula, right. So, this is how you should be calculating sample mean. So, just add all these values divided by 27. So, you will get mean. Calculate sample standard deviation. We know how to calculate sample standard deviation. Then at 26 degrees of freedom, t value is 2.05, right. Now, once you are done with this, you are supposed to calculate lower limit and upper limit, right. So, how it would be? So, this is 43.89 plus minus 2.05, let us take only values up to 2 decimal points, right, into S is sample standard deviation is 25.28 27. So, if you solve this question, you will get these two answers, right, upper limit and lower limit. So, before moving on to next slide, let me tell you what we have done today. In today's class, we have looked at how to find out confidence interval for a given question. We have seen two cases especially over here. We have calculated confidence interval for those wherein population standard deviation was given and when population standard deviation was not given. So, when standard deviation was unknown, what we did? We just used sample standard deviation to solve the question, and instead of z distribution we have used t distribution. So, t distribution is not the probability table or just like z table, because z table gives you that the probability that within which a population parameter will fall, right. The importance of t table is that it approaches towards z table as we increase degrees of freedom. So, at lower degrees of freedom it would be quite a fatter curve, just like this curve, and if you increase sample size it becomes a curve like this, right. So, before moving on to next topic, this is what I wanted to summarize. In next class we will have some more questions on let us say how to find out confidence interval of population proportion, how to find out sample size, so that you can come up with accurate answers. So, with this let me finish here. Thank you very much.